blessed good day, senior high school students. Welcome to physical science class. Before we start, let us recall our previous topic. I prepared questions for you to answer. I'm going to plus the question on the screen. I will use a roll it application and spin the wheel and selecting your name. Are you ready? Good. Here we go. Hernan, you're the lucky one. Very good, Hernan. It's clear that in our previous topic, you learned the collision of neutron stars, supernova, the elements formed naturally in an extreme environmental condition of our early universe, through nuclear reactions that occur in the core of the stars. Today, we will discover how the elements are made by studying the concept of atomic numbers, which led to the synthesis of new elements in the laboratory. The periodic table of elements way back many years ago is not what it looks today. There were many gaps or missing elements, meaning those elements were not yet discovered or synthesized. In today's lesson, we will focus on the processes by which elements are synthesized in the laboratory. But before that, you need to understand some essential vocabulary and concepts about atoms and nuclear reactions. By the way, I am Teacher Mary Jane, welcoming you once again to my physical science class, where you can learn physics in an exciting and fun way. Are you all excited? Alright, so let's have our game entitled Minute to Win It.
The game begins in 3, 2, 1.
Here are the mechanics of the game. There are 3 questions you need to answer. Fill out the blank statement with the correct word to complete the sentence. Use the clue such as the scrambled letters, the synonym and antonym, or the spaces of the blocks provided for each word. To win a prize, you need to encode the correct answer using the developer tab within a given time limit. Get ready!
The game begins in 3, 2, 1.
I am going to read the question twice. Here is the first question. The isotope notation of uranium-92 is its blank. Again, the isotope notation of uranium-92 is its blank. It refers to the atomic number itself. The clue is the antonym of the word superscript.
5, 4, 3, 2, 1, 0.
Very good! The right answer is subscript. So the number at the bottom, according here, tells us the atomic number or the number of protons. The proton or the proton number is the one that gives the identity of an element. For example, the atomic number is 92. Therefore, it's uranium. If its atomic number change, for example, it becomes 93, it's no longer uranium, but neptunium. Then, the number at the top refers to the combined numbers of protons and neutrons inside the nucleus of the atom. It's the total number of the 2 subatomic particles. Did you get the right answer? Good! For question number 2. The alpha particle has 2 neutrons and 2 protons but has no blank. Again, the alpha particle has 2 neutrons and 2 protons but has no blank. The clue is the scrambled letters and the backspaces where you can place each letter.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Very good. The right answer is electrons. The alpha particle has 2 neutrons and 2 protons, but has no electrons. So that is the alpha particle. So, class, the alpha particle is usually emitted during radioactive decay, and it has the same charge as that of helium, which is 4/2. Why? Because accordingly, it also derived from helium atoms. Let's proceed to the last question. Beta decay is made up of high-energy electrons and not of neutron and blank. Again, beta decay is made up of high-energy electrons and not of neutron and blank. The clue is the opposite of the word electron.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Very good! The right answer is proton. Going back to fill the statement with the correct concept, please be reminded that beta decay is made up of high-energy electrons and not of proton and neutron. And of course, additional information for that, just like an alpha particle, beta particle is also emitted during radioactive decay. The difference is that it is made up of high-energy electrons and not proton. Okay, remember that. The loss of beta particles is also observed in some synthesis of elements in the laboratory. The beta particle has this symbol. Another additional piece of information, the addition of proton to the nucleus, the neutron capture by nucleus followed by beta decay, and the addition of proton using nuclear projectile are all possible methods of synthesizing new elements in the laboratory. We will also discuss that later. Alright, who among you get the perfect score? Wow, very good. You will have your prize later. But before that, I actually invited a very well-known professor. She's a physicist from the American Filipino Teachers Association. So, I will be the one to facilitate for the discussion today and for some activities. Okay, let us all welcome here on our virtual floor, Ma'am James Tutiro. Thank you, ma'am, for allowing me to share my knowledge with the future scientists of this class. But first, let me inform you that I'm here to facilitate a simple test. Before we start, I want to invite your family members to join if you are studying at home. Alright, now if you have your family members or classmates with you, we can now start the activity. Our activity today is called Think, Pair, Share. Pairs up with a partner and discuss the given questions for a minute or two. Make sure that you have your pen and notes to jot down important ideas to talk about. It's a time that you can share your inside voices, take turns, and of course avoid interrupting your partner. I know that it's more comfortable when you are just in a small group, right? So now here is a big question for you to answer. So here's the question. How does the concept of atomic number lead to the synthesis of new elements in the laboratory? That's actually a big question that requires, of course, a big idea. So you're going to use a concept map or any creative presentation such as jingle, poem, etc. to present your answer. I will use rubrics in assessing your performance.
A few moments later.
Alright, that's a good presentation indeed. However, I noticed that some of you answered that through mixing chemicals, you can synthesize new elements. Let me tell you that way back thousands of years ago, alchemists thought that they could transmute elements from other elements by simply mixing them. Actually, during those times, they wanted to synthesize gold out of the lead. They were unsuccessful because they were just simply mixing elements. So today, it's clear that if you want to change the identity of lead, which has an atomic number of 82, you need to take up 3 protons out of the nucleus, so it would reduce its atomic number to 79, which would result in gold. Aha! I know what you're thinking, huh? Maybe now you want to synthesize gold in the laboratory. Well, it's not that simple. All the gold found in Earth, and even the one in your finger, undergone processes called nuclear reactions, which were created by the stars billions of years ago. Though it is possible to synthesize gold in the laboratory, but the creation of that noble elements or metal requires expensive processes, more than the processes of mining it. So, to give you more understanding regarding the processes involved in the making of synthetic elements, I just want you to bring to the virtual field trip and a gallery of the International Laboratory. In doing so, let me introduce you to your tour host, MJJ Thompson, who will give you the information about some properties as well as the discovery of the missing elements in the periodic table. MJJ, please take the virtual floor. Hello guys, and welcome to our Gallery of International Historical Laboratory. By the way, I'm your tour host, MJJ Thompson. Simply call me MJ for short. Hanging here on the wall beside me is my Spider-Man, named Ernest Rutherford. By the way, I'm just kidding. He's not a Spider-Man, but this photo belongs to Ernest Rutherford. This man, a Nobel laureate in physics, in 1911 conducted a globe foil experiment. He disproves my great-great-grandfather's Sir J.J. Thomson plum spotting model of the atom, which had negatively charged electrons embedded within a positively charged soup. Rutherford used an alpha particle emitter and a thin gold foil and bombarded it with alpha particles. He observed laboriously in the dark room that most of the alpha particles passed through the foil. He concluded that the atom is mostly an empty space and not embedded together with a positively charge. He also observed that there were alpha particles deflected sideways and others bounced back. He concluded that the positively charged is confined at the center and the negatively charged particle just orbiting around it, just like planets revolve around the sun. To give you some more ideas regarding the elements, let's go to the laboratory. Well, this is the periodic table of elements way back 1913. Do you have any idea if what are the gaps in the table or in the periodic table corresponds to? Alright, the gaps in the periodic table corresponds to the atomic numbers of elements. How about how the scientists fill the gaps in the periodic table? Any one of you here has an idea? Very good. So, the scientists fill the gaps of the periodic table of elements by synthesizing elements in the laboratory. So take a look at this. He's Henry Jeffreys Moseley, an English physicist, proved that major properties of an element are determined by the atomic number and not by the atomic mass or weight. and firmly established that the relationship or there is a relationship between atomic number and the charge of the atomic nucleus. Mosley also published a paper on the arrangement of elements in the periodic table based on their atomic numbers. He also stated that there were 3 unknown elements between aluminum and gold. Can you identify those missing elements in the periodic table? Okay, good job! Mosley identified gaps in the periodic table for technetium with an atomic number 43, promethium with an atomic number 61, and rhenium with an atomic number of 75. But he missed hafnium, which has an atomic number of 72 because its discovery had been erroneously claimed. The good thing is, those elements were synthesized later and fill the gaps of the periodic table of elements that we have today. In 1919, Ernest Rutherford carried out successfully the nuclear transmutation. Nuclear transmutation means converting one chemical element or an isotope to another that involve a process of changing the number of protons and neutrons in the atom. Then, in 1932, the student of Ernest Rutherford named James Chadwick discovered the neutron. This was a previously unknown neutron particle. It has the mass or the same mass as proton but has no charge. The combined numbers of protons and neutrons is the atomic mass of the atom. By the way, that is how Dmitry Ivanovich Mendeleev arranged the periodic table before, according to each increasing atomic mass or weight. But he noticed inconsistencies. For example, the cobalt and nickel. Cobalt has an atomic mass of 58.9, while nickel has the atomic mass of 58.7 only. However, cobalt was placed first in the periodic table of elements, even though it has a greater mass than nickel. However, they couldn't change their places on the periodic table because the properties of cobalt were more similar to its respective group, such as the rhodium and iridium. Finally, the first man-made element was discovered in 1937 by Perrier and Segre in Italy. Technetium was derived from the Greek word technetos, means artificial, because it was made in the laboratory. Then, in 1940, Del Corson and Emilius Segre synthesized elements 85 using cyclotron. Recall that there are missing elements in the periodic table. As you go back to your virtual classroom, your facilitator will ask you what are those elements. Now you can find that here in the gallery. So I will let you to sightsee for a while. At this juncture, your host MJJ Thompson signing out. Okay, thank you so much MJJ Thompson for a very informative and comprehensive tour. So now students, can you tell me what have you discovered in the virtual lab? What do you call the element with atomic number 43? Very good. The element with the atomic number of 43 is called technetium. So how did the first man-made element synthesized in the laboratory? Yes, Randy. They bombarded molybdenum with deuterons, an isotopes of hydrogen. Deuteron has 1 proton and 1 neutron. They use the particle accelerator to speed up the proton to overcome the repulsion between the target atomic nuclei and the proton itself. When they hit molybdenum with deuteron, the proton attaches to the nucleus and neutrons are released. The addition of 1 proton to the atomic number of molybdenum turns it to 43, or element technetium. You can see in the equation below that the processes or the nuclear process is written this way. The plus sign here tells us the combination of molybdenum and deuterium, which read as combines with or reacts with. The number on the side of deuterium can tell us three things: the number of protons, the number of neutrons, and the mass number. However, the number at the top of molybdenum tells us the mass number of the element. If you count the number of a proton plus neutron, it is equal to mass number. The number below tells us the atomic number of the element. Suppose you add one more proton here, it will no longer be molybdenum. Element 85 was synthesized using a cyclotron. First, they bombarded the proton of bismuth with the fast-moving alpha particles. As a result, protons are added up to the nucleus and form astatine. Its name is derived from the Greek word astatos, meaning unstable. The two other elements with atomic number 61 and 87 were discovered through studies and radioactivity. Okay, class, we all know that in 1930, the heaviest element known was uranium with atomic number 92. Alright, so as part of your activity, I want to regroup you into two as element 94 and element 95. What I want you to do is to make a timeline of new elements. Then, identify at least two new elements that form heavier than uranium that were discovered during and after World War II. You can use your cell phone to search for those elements. Get ready to discuss how they have been discovered or synthesized in the laboratory. Please be guided by the timeline below. So the first one is done for you. Very good presentation, senior high. All of you deserve a thumbs up. I commend you and your teacher in physics for making all of you active learners. You all did a good job today. Ma'am Mary Jane, back to you. I hope that you will invite me again to your next physics class. Wow, thank you so much, Professor Jane Juderon, for a very fruitful discussion with the senior high school students. Wow, it's really a fulfilling day today, isn't it? And I'm so proud of you, senior high school. By the way, I just want to add that elements heavier than uranium-92 are called transuranium elements. According to Britannica.com, transuranium elements refers to any of the chemical elements that lie beyond uranium and that lie beyond uranium in the periodic table, those with atomic numbers greater than 92. Elements 96, 97, 98, and 101 were synthesized through alpha particles bombarded by the cyclotron. Element 99 and 100 were discovered from the debris of the hydrogen explosion. Its discovery is pretty interesting, isn't it? So, the energy that comes from the blast makes neutron capture possible and resulted in the formation of heavy elements including the said elements 99 and 100. The elements heavier than 103 are considered as super heavy elements. They are synthesized using heavy nuclear projectiles. The modern periodic table that we have today has up to 118 elements. Oganesson 118 has the heaviest element known so far. However, maybe soon, some of you become a physicist or scientist who will strive in the field of nuclear physics and can synthesize elements heavier than Oganesson. And since you know that you have learned enough from Professor Jane Juderon, you can now explain how the concept of atomic number led to the synthesis of new elements in the laboratory. Okay, who among you can explain this concept? Very good. The concept of atomic number gives way to think about that the proton number has something to do with the identity of each element. Because of the concept, scientists found ways to manipulate this number in the nucleus of the atom to transform one element into another element. Now, why do you think the idea of alchemists helps scientists to widen their concept about the elements? Today, with the help of Professor James G. Theron and the international guide MJJ Thompson, we learn the synthesis of elements in the laboratory. You also learn some important nuclear processes like alpha decay and beta decay. Add to that, you learn the atoms, the concept of atomic number that leads to the synthesis of new elements in the laboratory. Those processes like that of neutron capture, the addition of proton to the nucleus, and the addition of nuclear projectile to the nucleus are also tackled. To determine how far you have learned in our topic, I'm going to give you a 10-item formative assessment. I will let you to check your own work using a ZipGrade application. So by the way, you already downloaded that in your mobile. Okay, for your assignment, write in your journal your insights about the topic. Also, include perceptions on how you find the said topic useful to you as a student and as a science enthusiast in the future. Before I end up with my lecture, let me leave a simple message for everyone that I hope will motivate you. Change is inevitable. It is not permanent. For several years, ancient Greek philosophers thought that the universe is comprised of only 4 elements, but they were proven wrong. Decades passed by and there were changes in the periodic table of elements. Many elements were discovered, but still there were many gaps or missing in the periodic table. Presently, all the gaps in the periodic table of elements are filled out. At this time, we are currently challenged by the crisis brought out by this pandemic, and it seems there is no solution to how this will end up. Class, have faith in God. Also, keep in mind to be hopeful that change is the only thing that is permanent on this planet, and our struggles will also pass. That's all for today. Bye for a while and see you again in our next physical science class where you can learn physics not that tough, but in an interesting and fun way. I am Teacher Mary Jane, signing off.